Hello and Assalamualaikum. We are from Group 5 and we are going to present on our MANOVA final presentation. So, we have two objectives. The first objective is to investigate how density, angle of inclination and amount of fluids will influence the time taken for the fluid to flow. Our second objective is to investigate how density, angle of inclination and amount of fluids will influence the distance travel of the flowing fluid. So for our experiment, we have two numerical variables that we are measuring. The first one is the time taken in the unit seconds, and the second one is distance travel in unit seconds.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Sadiq bin Ahmed Latfi. My metric number is 197844. I'm going to explain about the preparation before we conduct the experiment. The experiment consists of two variables, which are the time taken and the distance traveled of the fluid to flow in the inclined plastic surface. Both variables has the same equipment. Prepare three types of fluid. Later we see the fluid. Inclined plastic surface, table to record the data, stopwatch, ruler, and the tissue to make sure the plastic surface clean. There are three types of fluid that has a different density we use in the experiment. First, oil with 0.93 gram per centimeter cube, water 1 gram per centimeter cube, shampoo 1.5 gram per centimeter cube. For each fluid, we use different amount of the fluid, which are 2 ml, 4 ml, and 6 ml. For each amount of fluid, we're gonna measure the time taken and the distance traveled in different angle of the inclined plastic surface. We use 10 degree, 20 degree, and 30 degree of inclined plastic surface. So we have 9 parts for each variable. For starting point, we fit a point where the fluid is poured before the measurement is taken. After that, we need to record the data. Before that, we need to measure. For time, we use stopwatch to measure the time taken for fluid to flow in 30 cm inclined plastic surface. 30 cm inclined plastic surface is the constant for variable time. For distance, we use ruler to measure the fluid flow in the inclined plastic surface in 2 seconds. 2 seconds is the constant for the variable distance. Record the data on the table and repeat the experiment for each part 4 times to get the average.
Alright, this is Hisham and this part is about MANOVA performance. SPSS statistic IBM software are used to calculate multivariate ANOVA testing analysis. And the first step was to insert the raw data, as first column is density, followed by volume, angle, time, and distance. A built-in tool was used by clicking Analyze, General Linear Model, Multivariate, and then dependent variables and fixed factors were determined, as time and distance were dependent variables. Some options were set, such as descriptive statistics, estimates of effect size, and others were to calculate the multivariate test tables, and some descriptive statistics tables such as mean, standard deviations, and other valuable informations. After that, a report was generated. In this part, a multilinear regression was used to model the predict the time and distance with the effect of volume and angle of inclination as a factors. Code was generated where x1 is the volume, x2 is the angle, y1 oil is the time taken by oil, y2 oil is the distance taken by oil, respectively with water and shampoo. After that, sum of all variables were calculated, and matrices M1 and M2 were generated from the sums. After that, plot for distance and time were generated just to compare the actual data and the model data for all liquids, oil, shampoo, and water.
So next, let us move to the results and discussion. First of all is the raw result from the experiment. This table shows us the data collected when the experiment is ran. A total of 108 data is collected. Results from MANOVA. The first table obtained is the descriptive statistics. This table provides us the mean and standard deviations. Mean estimate the average response at different levels of one factor, while standard deviation provides the measure of dispersion or the spreading out of the data around the mean. For example, for the mean, solvent with higher density, which in this case is 1.5 gram of centimeter per cube, takes longer time to travel with smaller volume and inclined angle of surface. Hence, it is always have the highest average time taken. For standard deviations, distance traveled by the 2 mm of fluid with the highest density have the least standard deviations among the data. These tell us that this data is spread smallest. The relationship in this experiment is the time taken to flow for 30 cm will decrease and the distance traveled in 2 seconds will increase as the volume and surface angle increasing with the decreasing density. Next, we will go to the box test of equality of covariance matrices. This table gives us the information of null hypothesis. What is null hypothesis? Null hypothesis is that all levels of each factor are having the same mean and variance. However, in this experiment, we have the significant value equal to 0. Hence, it is smaller than 0.5. It is provide us the information that significantly difference and the assumption is broken. Hence, we could conclude that all the factors are affecting the time and distance traveled by the fluid. Next, the multivariate test. These tables give us the pillar stress, Wilks lambda, and Hotelling stress. This table provides us the actual results of one-way MANOVA. Also, in this table, the significance level is equal to 0, which is smaller than 0.5. Hence, this experiment is statistically significant. Confidence interval. This table illustrates the lower and upper confidence limit. We have a 95% confidence interval. As we know, the wider the interval, there are variety in the interval. In this experiment, parameters are uncertain because we have huge difference in data.
So we move on to conclusion. The first conclusion is the factors affect the response variable. This is because if we look at the raw data, we can see the display that the average of each data is changing, whether the trend is increasing or decreasing. So for the for the relationship between the time taken and the factors, it can be said overall it is inversely proportional to all the factors. Meanwhile, the distance travel is proportional to the all factors. So the relation between density, amount of fluid used, and angle of inclination between the time and the distance. So the density, as I said earlier, will, if the density increase, the distance will increase and the time will decrease. So the value is 0. It means that all the data fall down into the, is unlikely to fall down into the null hypothesis. So for our base data is 6 mm of water is flowing at different angle of inclination. This is because of the it has the smallest standard deviation, which is 0.02454. So it means that the data do not stray away from the center. So it is the best data and it does not move really far from the mean.